In this video, we're going to look at solving right triangles and also showing some additional applications of right triangles. So first, let's just recall that acronym SOHCAHTOA. It's going to be really important that we know this one. It's going to help us remember our three main trig functions. And that's sine of theta is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. And tangent theta is opposite over adjacent. Again, and this is used when we are not looking at, I mean, it does work when our triangle is graphed on a coordinate grid, but if it's not, we can't use that X, Y, R option. So we need to know this. And then our Pythagorean theorem, that a squared plus b squared equals c squared, or leg squared plus leg squared equals hypotenuse squared. Solve the right triangle ABC if A is equal to 53 degrees, 24 minutes, and C is 387.1 feet. Round to the nearest hundredth as necessary. So the first thing I want to point out is directions of solve the right triangle or any triangle just means to find all the missing sides and angles. Again, we talked about this in a previous video, but when we're labeling a triangle, we use capital letters to represent the vertices and those angles at each vertice or each vertex, and then lowercase letters to represent side lengths. So we know we've got a right triangle, so I'm going to start sketching this out. And I'm just going to sketch a right triangle. It doesn't really matter what the side lengths look like. It doesn't need to be accurate. It just needs to depict the information that we're getting. And how you choose to label this is up to you, but we typically always leave C as being the right angle because we've used lowercase c as the hypotenuse. So that's going to go opposite that right angle. So I'm just going to call this A and this B, which means that this is side A and this is side B. I'm going to fill in what we have. We know that A is 53 degrees, 24 minutes. And that C is 200 or 387.1 feet. So we need to find B, we need to find A, we need to find little b. We don't need to solve for little c, this is, or sorry, big C, because we know that this is a right angle or right triangle, so the measure of C is 90 degrees. So let's start by solving for B. Now, the reason I'm going to start there is because I know that the sum of my interior angles of a triangle is 180, so this is going to be a really straightforward calculation. I also know that the sum of these two angles has to be 90, they're complementary. So I can do 90 minus 53 degrees, 24 minutes to find the value of angle B. I'm going to do this the same way that we did before. Since I don't have any minutes to subtract, I'm going to take that 90 degrees and I'm going to do 89 degrees, 60 minutes, minus 53 degrees, 24 minutes. That gives us 36 degrees, 36 minutes. So there's our measure of angle B. That's one of our solutions. And I like to label my picture too, because the picture provides that visual, helping us problem solve and set up other equations to find other unknowns. Now, the next thing I need to find is the leg A or leg B. It doesn't really matter which one we find. I'm going to start with finding leg A. So I'm now looking at that side right there. So I'm going to use a trig function. I'm going to use sine because I have my angle of A. So sine of A is equal to the opposite side over the hypotenuse. So I'm using two known values. So I'm going to use sine of 53 degrees, 24 minutes is equal to lowercase a divided by c, or 387.1. I'm going to multiply both sides of this by that 387.1. To solve for A. And again, if we're using Desmos, we can't type in 53 degrees, 24 minutes. So we're going to need to type this in as 387.1 times sine of 53 plus 24 over 60. Rounding this to the nearest hundredth, that's 310.77. And this is going to have units of feet because it's a side length. Oh no, didn't want to erase that whole thing. Now we're going to look for side B. I can label my side A, that's 310.77 feet. To find side B, we actually have several options now. And we did really have some options for side A as well. And that's one of the nice things about these triangles and all these relationships is that we do have different ways of looking at the picture. So if I'm looking for side B, I could use sine of angle B is B over 387. I could do cosine of angle A is B over 387. I could do tangent of A is 310 over B. Tangent of B is B over 310. I could also use the Pythagorean theorem. I've got two of the three sides of a right triangle. So there are a whole lot of options. However, one of the things that I try to always do is when I'm solving a right triangle or any triangle like this is to work with the given values as much as possible. So I'm going to try to avoid using this 310.77 feet. I'm going to try to avoid using this 36 degrees, 36 minutes, because these were calculations that I made. If I made an error making any of these calculations, then I'm going to further see that error in my last calculation for B. So if I can avoid that, that does sometimes help, especially in a platform like Delta Math, where you're just checking your answers. You're not, I'm not tracking your work. So definitely something that I always like to do, but not necessary. You could use these values as well. So if I'm trying to avoid using, or if I'm trying to avoid using these calculated values, and I'm trying to find this, I'm going to use cosine of A is B over C. So cosine of our angle is adjacent over hypotenuse. Cosine of 53 degrees, 24 minutes is equal to lowercase b. Oops. Lowercase b divided by 387.1. So again, not having to use any value that wasn't already given to me. Still multiplying both sides by 387.1. We can find that value of b. And we can say that b is 230.80 feet. So these were the three unknowns for that right triangle. Let's try one more. Solve the right triangle if side A is 76.4 yards, side B is 39.3 yards. So all we're being given are those two sides, and then we still know that third angle C. So again, starting with a picture, labeling it however you want, I'm going to be consistent, A, B, C. We know that C is our right angle. The side opposite A is 76.4. The side opposite B is 39.3. So the first thing I'm going to solve for is side C. I can't solve for, well, I could start solving for angles, but I'm going to start solving for side C first. It's just very obvious and apparent using the Pythagorean theorem. So we've got 76.4 squared plus 39.3 squared equals C squared. C squared is 7,381.45. I can't figure out where my decimal is in my work. And then I'm going to take the square root of both sides. That gives me 85.92 yards, keeping those same units. So now we have C, 85.92 yards. And now I need to solve for angles A and B. So I'm going to start with angle A. Again, using that idea that I want to try to use only the given values, not any of my calculated values. That's not always going to work, and it's not always going to be obvious, but if I can avoid it, I'm going to try to. So if I have these two given values, I'm going to use tangent because that's my opposite and my adjacent side to angle A. So tangent of angle A is 76.4 divided by 39.3. And then to find angle A, we're using that inverse trig function of tangent. And I'm not going to divide that and find the decimal. I'm just going to type in that fraction the way it is to make sure I don't lose any accuracy. A is 62.78 degrees. And then to find our remaining angle B, here I am going to use those calculated values for the simplicity of the calculation. We know that the sum of my interior angles is 180, or the sum of those two acute angles has to be 90. So then angle B is going to be 90 minus what we just calculated for angle A. (62.78 degrees). Angle B is 27.22 degrees. And those are our three values to solve for that triangle. In applications of right triangles, a lot of times we deal with angles of elevation or angles of depression. I'm going to let you read that, but those figures below A and B do give a great illustration of your angle of elevation or angle of depression. It has to do with starting with that horizontal and whether you're looking up and having a positive angle or looking down and having that negative angle. Well, we're going to keep it positive, but whether the angle is below the horizontal or the angle is above the horizontal. You are at a height of 30 feet in a building. Looking across the street, you see another building and want to know its height. You calculate the angle of elevation to the top of the building to be 50 degrees and the angle of depression to the bottom to be 20 degrees. Find the height of the building across the street from you, round all values to the nearest tenth. So with these types of problems, absolutely want to start by sketching out a picture. So here's our ground. Here's the building that I'm in. And I'm at a point of 30 feet. So this is 30 feet. Now, from this point that I'm in, I'm looking across the street to this other building, and I want to know, how high is it? How tall is this building? The angle of elevation, actually, let me use a different color. The angle of elevation from where I'm standing to the top of the building, they said was 50 degrees. So this is 50 degrees. And then the angle of depression to the bottom of the building is 20 degrees. So I misspoke. We are going to keep these positive, even though we are going that clockwise motion, but just to illustrate the picture. Remember, we're no longer in standard position. We're just illustrating triangles outside of the coordinate system now. Now, it's important to note that this horizontal does create a right triangle. We're going to be using that relationship. We also know that this length right here on our second building is 30. We don't know what this is, so I'm going to call that X. So some things that we know. We know that the height that we're looking for is equal to X plus 30. So once we find that value of X, then we can use that to find the value of H, or the height of that building. Now, to find X, we need to figure out some more information about this triangle, right? We only have an angle. Well, we have two angles. We don't have any sides, so finding sides is going to be really tricky. So what we're going to do is we're actually going to start with this bottom triangle down here, because we have an angle, we have a side, which means we can start setting up some trig functions. And what we're going to try to do is solve this bottom triangle for something to help us solve this top triangle. So we're going to solve for this length right here, y, the distance between those two buildings. Looking at our angle of 20, we have 30, which is opposite, and y, which is adjacent. So tangent of 20 degrees is equal to 30 over y. Multiplying both sides by y to get it out of the denominator, we get tangent of 20 degrees is equal to 30. And then we can divide both sides by tangent of 20 degrees to isolate y. And this is approximately 82.4 feet. So now looking at that top triangle, we have enough information that we can solve for X using, again, tangent. If I'm looking at that angle of 50, we've got the opposite side X and the adjacent side 82.4, or Y. So tangent of 50 degrees is equal to X over 82.4. And to solve for X, we're just going to multiply both sides by 82.4. We find that X is approximately 98.2 feet. And thinking again back to what they're asking us to find, they want us to find the height of that building, which is what we calculated to be X plus 30. Now we have the value of X. So the height of our building is equal to 98.2 plus 30 feet, or 128.2 feet.